Hi, my name is Craig. I am the lead for Cloud Observability at Aurora. I'll talk about Aurora more in a second. I've been at Aurora for a little over 5 years, going on 6. I'm based in California, grew up around Chicago if you care. If you want to connect with me on LinkedIn, you can. If you connect with me on LinkedIn, you might see a few interesting things. One is my background is actually in computational chemistry. I did some research in quantum mechanics. This was a very, very long time ago. But the more interesting part is I was actually a chef for a while. I was a chef in Sydney, Australia, and Florence, Italy for a couple of years. So I will warn you, if you want to talk to me about tech and food, I would lead with the tech stuff because I tend to ramble quite a bit when I talk about food. So who is Aurora? Aurora is essentially a self-driving car company. We are focused primarily on trucking at the moment, but we are definitely interested in kind of the whole ride-hailing business in the future. Being in Texas is interesting because some of you might have actually seen our truck out on the road. Our primary routes are between Houston and Dallas to El Paso, and we just announced routes into Phoenix opening up later this year. The mission of Aurora is to deliver the benefits of self-driving technology safely, quickly, and broadly. I will mention that notice that safely is the first term, not the last one. Safety is a big concern for us. Early in 2021, we acquired a division of Uber called ATG, which is essentially our self-driving division. This will become important when I start describing how our observability platform matured over the years. We are an AWS shop. We're also a Kubernetes shop. So the two obviously means we have a lot of EKS. We have essentially 4 major types of clusters. There's core infrastructure, which everybody kind of has to have. This is things like Argo, Harbor, our image repository, things like this, things that manage all of the clusters. Then we have several big batch clusters. We have kind of internal R&D, and then we have clusters that serve services that are going to be for customer visible things. I want to book a truck next Tuesday at 10 a.m., things like that. Or where is my load currently? So what's important is the batch clusters are by far our largest, but the most important ones are the customer visible ones. We use a lot of Terraform. I'm a huge believer, personally a huge believer in Infra as code. Terraform, I have a very kind of mixed feelings about. Also can ramble about that for quite a while. We have multiple layers of abstractions. And the reason these layers of abstractions are important for this conversation is it's difficult for an individual developer to know exactly where their data is going in the case of logs or metrics. And it's often difficult for them to know exactly how that data is getting there. They might pull in a library that pulls in a library that pulls in a library that pulls in a library that actually sends logs to standard out that we then capture. They don't necessarily know that all the time. This becomes really important for the migration story. So where did we start? So when I started, again, roughly 5.5 years ago, we were all open source, self-hosted Prometheus and Thanos, and then with Grafana, a dated version even at that point. We have a strict no AGPL policy. Therefore, when Grafana changed their licensing terms, we were kind of stuck on the non-AGPL version. We did add a logging vendor, which was an interesting challenge. Mostly, the largest challenge was essentially developer participation in using said logging vendor. When you host your own solutions internally, open source or not, you have to manage your own headcount. This becomes important in just a second. And in this specific case, some of it was a little bit clunky, specifically Alert Manager. Alert Manager worked for us. We were able to send alerts, but it was not easy and definitely not fun for the developers to add new alerts and manage their alerts. So these issues started becoming a lot bigger when earlier I mentioned we acquired this division of Uber in early 2021. This changed things overnight. What happened is Aurora was several hundred people. We acquired this division that was twice the size of Aurora at the time. i.e. we grew 200% literally overnight. So all our problems, anything that was a little annoyance, like I said, Alert Manager, became a big problem, again, literally overnight. One of the reasons that I call out kind of the headcount issue is we got a bunch of new people, so headcount was essentially frozen, but we had money to spend. What this essentially meant is we moved from open source to vendors. At that point, we chose kind of best of breed vendors, the best metrics vendor we could find, the best logging vendor, et cetera. So we chose Chronosphere. If you know the history of Chronosphere, Chronosphere basically spun out of Uber, and so there were a lot of people that knew each other. We were really early in Chronosphere's kind of journey, and so we saw a lot of, we helped them develop their product over time. They also, ATG also used Honeycomb, and so there was a lot of engineers who really loved Honeycomb, so we continued to use Honeycomb. Again, the best of breed. We did not have this desire to have kind of a single vendor, when that becomes important in a second. Honeycomb is great. A lot of engineers really loved it. It has simple dashboarding. It has a very kind of Datadog approach in that it's not open standards, but it's easy to get started. The easy to get started, also super important. And then we had other data sources. We had, at that time, a decent-sized data lake that has since grown monstrously large. And that data lake does have data that we do want to cross-correlate with some of the cloud observability. Most notably, the data we have in the data lake is cost data. That's probably the most important one. And then you're in AWS, you can't avoid CloudWatch. Things like Lambda will only send the CloudWatch, we'll send the CloudWatch by default. Other things like advanced RDS metrics are only available in CloudWatch. So CloudWatch is just naturally there. So what problem did we have by having all these best-of-breed vendors? Troubleshooting the kind of Swivel-Chair problem, browser tabs, whatever you want to call it. Things as simple as what time zone you're in. So again, I'm from California. The the headquarters for Aurora is in Pittsburgh. All their trucks run in Central Time. Some dashboards default to UTC. You can see between changing, if you're changing these different tabs, trying to look at the logs in one place, traces in another, CloudWatch data somewhere else, metrics somewhere else. And if all of them are in different time zones, just by chance, it can be a little bit painful. And that's not an impossible problem to solve, but it's painful to then try and correlate what is actually leading to the problem you're trying to solve. So the decision was made that we wanted to try to fix that problem. Again, I mentioned that we have multiple different types of clusters. The most important ones are not our biggest ones, but they have the services that are customer visible. And so we wanted to prioritize those clusters, those services, above everything else. And one of the things we wanted to do was make it simple. Simple from the perspective of the developers. One of the big challenges that Aurora has is we have these trucks driving down the roads. These trucks have LiDAR, they have sensors, they have cameras, they have a computer running in them with a real-time operating system. The breadth of engineering skill at Aurora is very, very wide. So you have very, very technical people in disciplines that have no understanding of the cloud, literally none. They don't understand how it works. So simple, from the perspective of all this broad set of engineering skills, is a very, very low bar when you start factoring in the lowest common denominator between all of them. Single pane of glass was one of the ways we really, single pane or first pane of glass was one of the ways we really wanted to make this simple for people. So at least all the data was in one place. Prom compatible was a very, very big deal for us. Again, big Kubernetes shop. We had a huge investment in Prometheus, dashboards from the open source community, alerts from the open source community, et cetera. We had a big investment in Prometheus. The first one, single pane of glass, is why Chronosphere didn't work for us. At that point in time, Chronosphere only had they had a metrics product and they had a brand new tracing product. They did not have a logging solution at all. Meanwhile, Prometheus compatible made Honeycomb a non-starter. Honeycomb, again, much like Datadog, has a very kind of prescriptive solution, which makes it really easy for people to get started. but it doesn't necessarily support all the open standards. So this is why we didn't continue on either the Chronosphere or Honeycomb paths. And if I'll mention it, if anybody is aware of CloudWatch and AWS, CloudWatch was also a non-starter as a complete observability solution. Profiling, lastly, was also of major interest. I will note it was of interest. I will touch on that a little bit more in a minute. So why did we choose Grafana? Obviously, it has the three main pillars, and then it also has profiling with the acquisition of Pyroscope a couple of years ago. The PromQL support was great. They have a very well-supported Helm chart that made it very easy for things to get started. We had looked at other vendors whose Helm chart was not as great, which meant that it would take more effort from our engineers to not only get started, but then support it over time. There is a lot of interest in some kind of low-code, no-code option for sending data. Therefore, eBPF was of significant interest, and the Beyla product was something we definitely were looking to use extensively. And then lastly, the open source nature of Grafana was super appealing. It meant it gave us the option of contributing or making local changes if we really had to, and chief among them was the agent. Not all agents are open source, and so moving to an open source agent had this potential for us to contribute, again, either internally or back to the project. As it turns out, we don't actually have time to do that, but the potential is still there. The first thing we migrated was metrics. This was just by coincidence. It turned out the Chronosphere, we're migrating from Chronosphere specifically for metrics. The Chronosphere contract was up first, and then the Honeycomb contract expired 6 months later. So metrics migration was first. While we were migrating from a Prometheus vendor to a different Prometheus vendor, it seems like that would be relatively straightforward, but there are tons of little nuances that made that actually a little bit more difficult. Alerting is one big one. I mentioned that we used Alert Manager in the early days. And I think part of the problem with Alert Manager is because there isn't a lot of standards on exactly how alerts work. There is this little bit of nuance in how the different vendors actually use alerts. And so modifying all the alerts from the Chronosphere format to the Grafana format took a little bit of time. Things like recording rules, the exact implementation of things like service monitors, all these little nuances meant it was a whole lot of effort to do this migration. Also, right-sizing the agents was also another big problem. The Chronosphere agents ran as started getting into a little bit of Kubernetes terminology, but it ran as a daemon set, whereas Grafana's agent does not. That presented a whole bunch of different challenges. Familiar, daemon sets just run everywhere, which means they all have to be the same size, which meant we had hotspots. And dealing with those was difficult, but all that knowledge then essentially went away by moving to Grafana because it's different paradigm of how they manage their agents. Again, not good or bad, just different. PromQL to PromQL, still a bunch of challenges. Fortunately, all this migration was handled by the team I work on, and we were able to do the bulk of this work over a couple of months, a bunch of prep work that led to the actual cutover happening somewhere in 30 to 45 days. Some things happened relatively quickly, other things took a little bit more time. But still, roughly a month, we were able to do the cutover with almost no involvement from all of the development teams. Almost no. This is a little foreshadowing for the logging adventure, which was significantly different. One of the other big problems we had was billing differences. How vendors bill is just different. How they want to attract people, or how they want to appeal to certain markets, et cetera. The biggest difference was Grafana bills by cardinality, Chronosphere did not. And so dealing with these billing differences was a super big concern, and you don't know ahead of time whether you're going to run into problems or not. When you bill on X, generally, as a vendor, you make X data available. If you don't bill on Y, you're not necessarily going to make Y data as available, which means the cardinality data that Grafana built on wasn't necessarily available as easy as we would like in the previous vendor Chronosphere. So we were super concerned about what could happen when we changed over. The other thing we really liked about Grafana was the default dashboards that we got right out of the box. Specifically a bunch of cost dashboards, which again was one of our big concerns, but we got a bunch of dashboards that gave us a lot of visibility into our costs right from day one. And then over time, later, asserts came along with the knowledge graph and had this potential to replace dashboards. For us, it hasn't quite worked out that well, but part of it is problems on our implementation. We have inconsistent use of labels by some of our services, but that's on our end to figure out. Logging, tracing, migration, as I mentioned, as I alluded to a little bit earlier, was much, much harder. Part of the challenge was there are fewer industry standards, specifically on logs. Traces, obviously, OTel is kind of the de facto standard now. When we acquired this division from Uber, there were some references to Jaeger still hanging around, but for the most part, those were relatively easy to remove. One of the things that is nice about vendors like Honeycomb is they make it relatively easy for people to start out and use their product. But this easiness comes with a cost, and this cost is essentially magic underneath the covers. That magic, when you move to a different vendor, that magic essentially comes bubbling up to the top, and you now have to deal with it. This is what caused so many problems for us. Is people were used to all these things being relatively easy with the previous vendor that were now just different in Grafana. Again, not better or worse, just different. We had lots of different client implementations. Unlike the prom world where you just have mostly service monitors, we do have some places where they use annotations for a variety of reasons. But for the most part, it's service monitors where you have an endpoint, you emit the data, and then some which is a pull style kind of paradigm. We also have a push paradigm with statsd. That's relatively small, but it is important to point out. In our case, the logging and even the OTel implementations were very different across all of the different teams. What this all kind of leads to is we had to basically handhold every single team to migrate to Grafana. And so this made this entire process take roughly a year. It was about 11 months, give or take. The other thing that was used for the other team that heavily used Honeycomb was the front-end teams, all of our JavaScript teams. They would send logs, traces, and metrics to Honeycomb because of how it was instrumented in their code. And they were able to relatively easily migrate over to the Faro SDK and to use front-end observability. One of the other cool things that front-end observability brought to the table was something that looked like Sentry. So we still use Sentry quite extensively within the company, not as much as I would like, but some teams still use it. In front-end observability, there is a feature that essentially has tracebacks, much like Sentry, and so they were able to kind of scale back their Sentry use. I think they still use it a little bit. Cost management, this again was one of our big concerns. And we have to control the amount of data we send. And there are multiple ways you can obviously control the data. You can control it from the actual implementation in your code at basically the SDK level. You just don't send a given metric, or you, more importantly, don't send a specific metric with a lot of labels, or with labels with a lot of values, aka high cardinality. But, or you can change the service monitor, you can change the config in the Alloy agent. There are multiple ways you can change it, but the problem is all those different pieces, they require some kind of redeployment internally. Even if you want to change the Alloy agent, which is not controlled by the dev teams, controlled by the central team, it still means a redeployment of that agent when there's always a risk something will go wrong. And so that's why we use adaptive metrics heavily, adaptive logs a little bit less so. but we still use them quite a bit because it is something we can change without requiring any kind of redeployment by any of the dev teams. We can just say, hey, you're suddenly sending a bunch more data than we were expecting. What happened? They're not sure. While they investigate, we can scale down. So again, we can deal with the costs. We don't have costs like in the previous talk where they talked about, hey, I deployed something on Friday, you come in Monday and the costs have gone nuts. And if you require a deployment, that could take, it could take a while depending on how adaptable the dev team is to redeploying their stuff. It can take some time. The adaptive telemetry products really help solve those problems for us. Our trace usage is relatively small. We have a certain amount allocated for how much we send for metrics, how much is our users' costs, are the various different kind of billing components within Grafana. Our trace usage is roughly half of what we have allocated. Therefore, adaptive traces is not a huge priority for us at the moment. Profiling is an area where, again, I mentioned that profiling was one of the big things that developers were really interested in before migrating to Grafana. As it turns out, they don't use it super heavily. There are some cases where they do use it, but not as much as they would have claimed to use it before we started migrating. Currently, how we work with profiles is we have it just enabled for our clusters. One of the things I didn't mention is we have these different styles of clusters. There's 4 different styles, the core stuff, the batch stuff, the internal R&D, and then the customer visible ones. There are roughly 30 different clusters. And essentially what we do is we enable profiling for a given cluster, kind of completely on or completely off. We are migrating to a paradigm where essentially it's an opt-in, where you add an annotation to your pod that will then collect profiles. Thus, the profiling is not, the cost management for profiling is not going to be as big a concern in the future, but much like the previous example where somebody enables something, they didn't realize that we're going to have a bunch of costs related to profiles. We can then, with adaptive profiles, just kind of tune it down for that one case without requiring a redeployment again. Single pane of glass was obviously where we're trying to get to. And you can see a picture here, a relatively simple one, where it shows metrics, logs, and traces all on the same page without having to flap between multiple different screens, again, with different potential time zones or other issues. So this has been a net win. There have been cases where teams have reported that a given kind of incident or issue that might have taken hours or days to resolve, say a year ago or 2 years ago, now takes them hours or even potentially minutes because all the data is in one place and they don't have to kind of constantly switch contexts and the different nuances that vendor A might have as opposed to vendor B. LogQL and TraceQL are great. They are super powerful, but they have a learning curve. We tried doing training. That has gone kind of mediocre, but the AI assistant is really where we're hoping the AI assistant is what we're hoping to really leverage to kind of bake that knowledge into the tool rather than into the developer. One of the other things we really wanted to do was show that a given thing might have caused your metrics to look funny. For example, you deploy a new version of your code, or you enable a feature flag. We've seen that multiple times today, where demos have feature flag enabled that caused some kind of problem. And so we want to be able to annotate the metrics for a given service, saying this is when a deployment happened, or this is when a feature flag was enabled or disabled, or ramped up to 50% or whatever. Initially, we wanted to use the Annotations API, which is kind of a standard prom-ish thing. That didn't work for us. Fortunately, the Grafana system is flexible enough that we were able to basically send that data to Loki as basically a log message, a very specifically formatted log message, that we could then annotate on individual panels via just a normal kind of LogQL query. Again, the point is the flexibility of the Grafana platform gave us the opportunity when solution A didn't work to pivot to solution B. I mentioned Beyla and no-code, low-code options for sending some of this data so the teams don't have to especially in the case of telemetry, instrument their services with the SDKs. They want to be able to just, quote, just have the data. Unfortunately, Beyla didn't really work out for us. We are still hopeful to get back to it. But for the moment, Beyla is not where we're spending a lot of effort. Where do we want to get to? SLOs as first-class item. Previous vendor, we use Sloth. If you're not familiar with Sloth, Sloth is a way to get something that looks like SLOs, which essentially has a combination of recording rules and alerts that make it, again, look like SLOs, but it's not really SLOs. We've run into a couple of problems with SLOs with Grafana that we're still continuing to work on, but we are still trying to make SLOs a first-class citizen and make that a priority to have SLOs across all of the services within the company. Controlling costs with profiling, I mentioned before how we're kind of changing from a kind of an entire cluster is enabled to more of an opt-in approach that is kind of in progress. SIFT investigations, metric forecasts had a lot of promise for us. We don't actually use them. We were really hoping to use the AI assistant. Unfortunately, the AI assistant has run into some snags for us. Basically, legal is concerned, and so they are still working through it. So right now, we're still not able to use the AI assistant because of legal concerns. It is not a technical problem, but we're still working through it. And lastly, more data sources. I mentioned that we have a big data lake. You can't get away from CloudWatch. We want to be able to add that, and the Big 10 approach that Grafana has gives us a bunch of options along with the API for creating our own data sources if we really want to. In the case of Data Lake, which essentially is fronted by Athena, which is the query engine that AWS uses, Athena creates some issues for us. It's an Athena technical issue. It's an AWS problem. It's not a Grafana problem, I want to be clear. But we could potentially solve that by writing our own version of the API, the Athena data source, if we wanted to. So again, the Big 10 approach opens up a whole bunch of options for us moving forward.